Now, first of all, I'm not going to assume that everyone here is convinced that AWS is the right place to be running your database. So let me talk about some of the benefits of moving it to the cloud. First of all, performance and scalability. Now, I've used the term RDS without sort of defining what it is. I should do that first. RDS is a relational database service. It's a managed service, and it's a service we've designed to make it as easy as possible to set up a database, to operate a database, and scale a database on the cloud. RDS supports 14 different instance types. They range from a T1 micro, which has got a gigabyte of RAM, single vCPU, right through to the R3 family, which go up to 244 gigabytes and 32 vCPUs. Now, I've got some customers where they're running SAP HANA, and that's not quite big enough. They want to run on X1s. You've certainly got the option available to you, but bear in mind that's not available within the RDS family. You'll need to manage those things yourself. Now, one of the nice things about about RDS is that if you're doing that sort of vertical scaling up and down in essence families, you can automate the whole process. So you set up a Windows. Sorry, I think it's okay. You can set up your maintenance windows so that you can schedule your scale up and scale down operations to happen in a downtime, which is a pretty magical sort of thing if you've come from an on-premise environment where you're having to provision memory and schedule extended outages. The other way you can scale RDS is through horizontally through read replicas. So if you've got a workload that's very read intensive, you can set up a farm of asynchronous read replicas that are driven off the master database and just reserve your master database resources to actually handling the commit transaction, the update transactions. Now, as well as a lot of what is that okay? The audio keeps dropping out. As well as making sure your databases can scale, there's a set of CloudWatch metrics that go alongside RDS that can tell you about the health of your database. Now, depending on the database engine, there's between 15 and 18 of them. They include the standard sort of CloudWatch hypervisor type metrics with CPU and disk I/O and network, but they also include some metrics into what your database engine is actually doing. So things like memory utilization, number of connections, read replica lag, the amount of free disk space. So and those metrics are down to 1 minute resolution. If you want to enable enhanced monitoring, you can actually go down to 1 second resolution and boost that to about 50 different metrics. So there's plenty you can see what's going inside your engines. Now, I mentioned RDS as a managed service. Now, if you think about your DBAs, they're a scarce resource. You really don't want them spending their time patching databases, applying endless security patches, making sure the backups have run the night before. You really want to make sure that you really want to leave that task to the RDS service and to AWS, and that's what we do. Developmental and operational flexibility. Now, some of my customers give me the best examples of this. Is sometimes they need to do a major application upgrade and they're quite nervous about it because there's schema changes involved, or they might be concerned about the performance impacts of a major upgrade, and they want to make sure before they launch do that release on a production system that the thing's been tested. So with RDS, what you can do is just take a snapshot of your production database and use that to launch a new instance, run your tests against that new instance, and then once the tests are completed, you shut it down, you stop paying for it. So it's a really great way to achieve some degree of operational flexibility. And the last thing is fault tolerance and availability. Now, with RDS, you've got the option of setting up a synchronous active standby replication schedule that works across multiple AZs, and it's as simple as enabling a checkbox in RDS. Now, you can achieve much the sort of thing yourself if you're using MS SQL with always-on availability groups, but I can guarantee you there's a lot more than a single checkbox to turn on. It's a lot of work. So that gives you some sense about what an RDS database, an RDS managed service has got to offer you. But what are some things you need to bear in mind when you're doing a migration? The first thing is business impact. So think about how much downtime can your business sustain without starting to impinge on the SLAs you have with your customers. What are another dimension is what's your current licensing situation with your database software? If you've got a whole bunch of perpetual licenses, you're able to bring them to AWS, or do you need to use our licensing? Another thing is support contracts. If you're using a third-party support organisation, will they be able to support your databases when they move to AWS as well? you need to understand what's going on in your existing databases. So are you using some fairly complex data types? Are you using materialized views? You need to understand a little bit, if you're using blobs, for example, what's the maximum size that those blobs could get to? That can be very helpful to know later on. Application complexity. So a really crucial thing is to understand where is your application code actually running, how much is running in the database itself in the form of stored procedures or stored packages, how much is running outside the database. This is oftentimes a really good time to look at what your situation is with third-party software as to whether you can start running that software, whether you can switch database engines as part of this migration. For example, quite a few of my customers are running Esri ArcGIS and on MS SQL, but they've got the option of moving that to Postgres RDS because that's fully supported by Esri. So they can save themselves a lot of license fees by doing that migration as part of the AWS migration. Integration points. So if you're planning a migration, you need to understand how your applications are connecting to the database. When you move that database into AWS, you need to make a decision. Are you going to move your application simultaneously, before or after? Because in those before or after situations, you'll be reliant on the performance of your connectivity between where the applications are living on premises and within AWS. So think about the direct connect and VPN implications of that. RPO and RTO. So when you move to AWS, there's a whole range of options you've got for improving, for enabling high availability solutions. So make sure that you're exploiting those solutions. You're not just relying on your current tried and tested DR strategy, which assumes you've got multiple data centers. And lastly, skills required. So what are the skills you're going to need to transfer to your organization for being able to use AWS? So we've taken those considerations into account, and what we designed was the DMS service. And the DMS service is designed to be as easy as possible to migrate your database with minimal downtime. That's the crucial thing, with minimal downtime. It can migrate your database from the most widely used commercial databases, so Oracle and SQL Server are those, to any number of, quite a few alternative open source databases, so MySQL, Postgres, Aurora, in its MySQL and already announced Postgres engines, MariaDB. Recently we announced support for MongoDB conversions as well in DMS, to Mongo to DynamoDB, and there's also OLTP to Redshift options as well. Now, let's have a look at what's actually involved in that migration. How do we keep your application running during a migration without imposing downtime? So this is a really classic setup. You've got your on-premises database on the left here. You've got a VPN over an internet connection, or you might have a direct connect, and then an AWS database sitting within a VPC. So that could be a self-managed database on EC2, or it could be an RDS instance. And you've got your application users pointing at the on-premises database. First thing you do is you start a replication instance within the DMS system. And what that replication instance will do is connect to both your on-premises database and your target database in AWS. The next thing you do is you select the schemas that you want to migrate. You may not want to migrate the entire database. You just might want to migrate a set of schemas over. And then you let the DMS service go through a sequence of creating the tables in the target database using some built-in rules, doing a bulk load of data from the source database into the target database, and there's a high degree of parallelism that happens there with multiple tables being moved over simultaneously, and then moving into a CDC or continuous data replication mode after that, whereby we keep track of all the changes in the source and move them automatically to the target. Now, a lot of DBAs get nervous about that CDC process. They wonder, is the replication instance sitting there running big queries against the source database? Is it going to impinge on performance? The answer is we've tried to optimize that as much as possible, and the data migration service is basically mining the logs, the transaction logs on the source database to minimize the impact, and it's just feeding through the deltas over the internet into the over the connection into the target database. And then lastly, once the migration has actually happened and you've run your tests, you're happy that everything's in sync, then it's simply a CNAME switch in your DNS system to direct your users to the target database. Now, the DMS is, we call the Swiss Army knife because it's quite versatile. It can deal with commercial databases, can do homogeneous, heterogeneous conversions. It handles OLTP to NoSQL conversions. It now handles Redshift. It's quite a versatile tool, but the sweet spot for DMS is really heterogeneous migrations where you need minimal downtime and where you've got no native solution. Now, a counterexample to that would be, say, if you're doing, say, an Oracle to Oracle conversion and you're already licensed for Golden Gate, that might be your best bet. It might be a faster and safer option than DMS. Another situation is if say you've got an MS SQL solution that you're wanting to migrate, again, a homogeneous migration to AWS. If you've got a fairly relaxed outage window and you can afford to just take a backup, just do that. Take a backup of your on-premise database, upload it to S3, and then restore it into an RDS instance, and you're up and running. And possibly, if it's a modest-sized database, you can do that on the weekend. But for other scenarios, which, to be honest, are the most common ones where you're wanting to do, where you've got minimal downtime and you're doing a heterogeneous migration, DMS is a good solution. A few cautions. I mentioned earlier that it's helpful to understand how big if you're using blobs in your database, how big they are. That can help you tune the migration process. You need to understand if you're using complex data types in your source system because some of them might be problematic, and I'll cover in a moment how you identify those. And also if you've got a high load under your source databases, if it's already under stress and that's what's actually driving your migration, even that CDC process might need some tuning to make sure it minimises the impact. If anyone wants to see me afterwards in the booth, I'll give you some war stories and some secrets for doing that as well. So DMS isn't a magic wand. What I strongly recommend is that you consider what your source database is, your target database is, go to the user guide and actually look up that combination, and we'll carefully document all the limitations and all the things that you need to be aware of when you're going from source to target, and read that and understand that because it'll save you a lot of time later on. Just some really common issues. If you're using the auto increment feature of MySQL databases, that won't be replicated to the target. I've been caught out with customers running Oracle databases where they have blobs or mutating blobs on tables with no primary key. That can cause an issue with CDC. You have to fine-tune the configuration options there as well. Well, in any case, there's a full dictionary of what all the various options are in the documentation. Now, I mentioned that the DMS tool is a good tool for doing a default schema conversion, but if you need to do something more sophisticated, like if you're wanting to do type mappings or introduce new naming conventions in your schemas, if you're wanting to bring over complex objects like constraints and triggers and indexes, and most particularly if you need to bring over stored procedures, so PL SQL, Transact SQL, over to a target database, you need to use the Schema Conversion Tool, which is a complementary tool that sits alongside DMS. That supports a wide range of options as well. Here's some of the source options for the Schema Conversion Tool, the usual commercial databases. Recently, we added Mongo to DynamoDB support, OLTP sources to Aurora. Redshift options are also supported from all these commercial OLAP-type databases. So it's a very versatile tool. Here's some of the outputs you'll get from the Schema Conversion Tool. I'm about to go into a demo where we'll see some real-world examples here. But what I strongly recommend to you, if you're interested in the migration, download the Schema Conversion Tool tomorrow, install it on a PC within your own network, point it at your database. You don't need any special database permissions, and get it to run that report. And that report will look at all of your schema objects, your tables, constraints, indexes, sequences, and then give you a sense of to what extent you'd be able to automate that conversion to any one of 3 or 4 different target databases. We'll do the same thing with all your stored procedures as well. So this is an actual report I ran earlier. See, that's a clean bill of health with the schema objects. A little bit of work that's needed. Well, actually, quite a bit of work that's needed on some of these package procedures and functions. But it's a really simple way to get some sense about how big a task is ahead for you. I won't go through all of these. It's a rapidly evolving list. Even since I did the slide, there's Sybase ASE has been, or sorry, SAP ASE, formerly known as Sybase, has been added to the list. The version's constantly evolving. General theme is that it supports a wide range of commercial to open source conversions, open source to open source conversions within the conversion tool. And then it also supports, as recently as this year, we've added a whole range of OLAP-type databases, so Teradata, Vertica, Netezza, Greenplum to Redshift conversions. I mentioned already the Dynamo to MongoDB conversions, SQL Server Data Warehouse, Oracle Data Warehouse. So we're putting a lot of investment in this tool to cover a wide range of scenarios. Now, as for what does a notional work program conversion look like? This is a typical sort of task list. From my experience, it's actually pretty accurate. The big ticket items in a migration process are really application conversion and remediation. So if you do have a lot of complex SQL sitting in stored procedures or stored functions, you might be spending a bit of time tweaking some of the work that the automated work that the schema conversion tool does. And then finally, there's no escaping the fact you're going to have to test it. If you're going to convert a schema, it's a large, complex undertaking. You're going to need to run some regression tests to make sure that the conversion's worked okay. So let me show you what it looks like in practice. So here's the test setup. This is a very common sort of migration, well, fairly simple migration schema. I'm using a sample database, sample organisation called Stadium Sports. They're a ticketing organisation. They're running in a data center. They've got an Oracle 12c database. The demo I'm running has got about 20 gigabytes of data. I've got the schema conversion tool downloaded and installed on-prem. In the target AWS side, I've got a target Postgres RDS instance. It's sitting within the VPC, and I've got a direct connect between them. Now, for the purpose of the demo, I've just replaced I'm using a separate VPC to host the Oracle 12c database, and I'm using a peering connection rather than direct connect, but the principles are exactly the same. So what's going to happen is the schema conversion tool will connect to the source database, and this is where I'm going to run my assessment process. I'm then going to connect the schema conversion tool to the target database to create a tweaked schema in the target. So I'm not just going for the purpose of the demo, I'm not just going to be satisfied with the default conversions. I want to mess around with it a little bit. The next thing is the DMS instance is going to connect to the source. It's going to connect to the target. And then I'm going to use the schema conversion tool to actually control that replication instance. So this schema conversion tool will be the dashboard as such for the actual whole process. Now that's the schema I'll be converting. It's actually a real-world schema. It's not super complex, but it's complex enough to sort of prove some of the principles. So the first thing is the assessment report. Thank you for hitting play there. So this is the schema conversion tool assessment report. The first thing I do is launch the project wizard. I give it a name, and then I tell it that I want to do an assessment of an Oracle source database. And the button there says I don't want to, at this stage I wanted to look at other engine options. So I want to look at some open source options. I enter some my Oracle credentials. They don't need to be specially privileged. They just need to be able to see the schema and enumerate the objects. Click next. It'll give me a list of all the schemas available for assessment. I'm going to pick the DMS sample, which is that sports ticketing database. And then what the tool's going to do is it's going to enumerate all of the tables, the constraints, the indexes, sequences in that source database. And for each of those objects, it's going to assess to what extent those objects can be automatically converted to the target schema. And it'll use as a 4-point scheme. So at one end of the extreme, it's a fully automated conversion. At the other extreme, the conversion's going to need a little bit of, it's going to need significant actions. And it's going to indicate that in the assessment report. And it will generate the assessment report for 3 different target schemas, 3 different target engines. This is the report for the MySQL conversion, RDS MySQL. So there's a little bit of work here on the constraints. There's a fair bit of work on procedures and packages. This is the significant actions. There's another report here for Aurora MySQL. Similar sort of story. You kind of expect that because MySQL Aurora and MySQL are compatible. And then here's the solution for a Postgres RDS. So it's actually got a clean bill of health as far as the schema object is concerned, and there's less work involved in the stored procedures. So if I was doing this for real, this is probably the one I'd choose as my open source target database. And in fact, in the demo, I've assumed that's happened. I've selected Postgres RDS as my target, and now I've stood up a Postgres RDS instance in my VPC, and I'm now about to launch a real conversion. So I go back into the Schema Conversion Tool. I say I want to create a new project, give it a name. This time I'll tell it that I want to do a convert. I want to be specific about my target. I want it to do an Oracle to a Postgres RDS conversion. So that's working, so that the Schema Conversion Tool will then interrogate the source database, get a list of all the schemas available for conversion. Oh, sorry, I need to enter my credentials first for the Oracle database, and then I'll have to enter my credentials for the target database as well. They're just regular old connection strings. We put in the URL of the database, the port number, the name of the instance ID. So I've come up with a list of the source schemas. And I repeat the process connecting to the Postgres database. So bear in mind, we're actually connecting to our target instance, and we're about to actually modify its schema or install schema objects on the target. So I'm going to select the DMS sample as my source schema, this guy here. That's my sports ticketing system. And the DMS sample, I'll click on that. It's going to enumerate all of the objects in the source schema. Now in this pass, I'm just going to focus on the tables and the tables and indexes. I'll do the stored procedures in the next cycle. This is actually done in real time, by the way. I'm not doing the demo now, but this is a real timings. I haven't sped up the film. Now I'm going to say convert the schema. Now what this is going to do is apply its standard built-in rules for a generic Oracle to Postgres RDS conversion. So it's going to perform the standard naming conversion, so uppercase Oracle to lowercase. It's going to do the standard mappings of data types, and we'll see what it comes up with. So I've switched it. I'm going to choose a table in the sample database called the player database. Sorry, it's in the target database called player. And I'm going to see what it's come up with as far as a schema conversion. Now, here you can see there's columns here called ID number, and they've been mapped as double precision. Now, the DBAs would say, oh, I don't like that. I don't like going numbers to double precision because that's a primary key, and that's not a great choice of a primary key. So what I'm going to do is create a mapping rule, a custom mapping rule, that's going to set up a mapping that says that for all columns that have got an ID, all table columns that have a name of ID, I want them converted to number in Postgres, not to floating point. Sorry, numeric in Postgres rather than floating point. And I do that within the Schema Conversion Tool. So I'm just defining the pattern I want to follow here. And I say I want to change the data type to... Now, big int could have been another option. That's a good option in Postgres, but I'll just go for numeric, and I'll save that rule. They'll handle all my primary keys labelled ID. Also, I've got foreign key references. They've all got suffix ID, so it'll say where it says a ticket will have like the stadium ID as a reference. So I want to convert all of those foreign key references as well from number to numeric. So I'm going to create a rule here that says any column that's got a suffix of ID, convert that from number to numeric. Instantly, while it's doing that, the default rule says that if there's a precision included in the Oracle data type, just preserve that precision. It's just this corner case where you don't have a precision in the source column that you have to that goes to floating point. So you may not need to do this on your own databases. So I've created that custom rule, and now I've got a custom rule. I'm going to rerun the conversion and see what it comes up with. So I click Convert Schema. It's going to overwrite my the potential schema or the prospective schema I've created on the right-hand side with the new mappings. And have a look at the player here, and here it's gone to change the column type to numeric, so it's no longer floating point. So that's actually the desired result I was after. So this new rule's been applied to every single table in that schema. And the next thing I'm going to do is go and have a look at the packages during the conversion. I think that's into that. So we're going to convert the packages. Thank you. I'm going to switch it into the assessment view for this packages demo. Now, what the assessment view does is, rather than saying here's a list of all the objects and here's the problems with it, it says here's an issue that's appearing at least once in your conversion, and here's all the occurrences of it. And that can be a better way of organising your workload if you're actually going through a migration process. So the example here is it's listed all my conversions, and I'm going to drill down into a particular package here called, a particular function called get event details. And this is an example of a clean conversion. So that's the source PL SQL, and that's the target PG SQL. So there's no issues involved in that conversion. That's just been a straightforward mapping by the conversion tool. So I'm happy with that one. I'll have a look at one that's got a problem with it, and that's one called transfer ticket. And this is the source PL SQL. And it's told me that there's an issue here that the converted function depends on the time zone settings. So we'll just have a look at what that means. Go down to the PL SQL and just scroll across. Screen real estate's a bit of an issue when you're using this tool, but it's got a reference to sysdate in the PL SQL, and sysdate isn't an intrinsic within Postgres. What it does is it maps it to a function that's part of the extension package we include in the conversion called Oracle Extension Sysdate. And what it's saying here is that just be aware that there's a time zone dependency that's been introduced by that mapping, and check to make sure that you've got the time zone set correctly. So that's an example of a package conversion. Now, once I can keep iterating on that package conversion. Once I'm happy with it, the next thing I do is I apply that schema to apply the schema I've generated on the right-hand side through my rules and my edits to the stored packages, and I apply that to the target database. Now, it's only at this point that I'm actually going to apply all the DDL that I've produced. Oh, you might need to hit play there. Thank you. It's only once I've actually done gone through all those rules that I actually apply my DDL to the target database, and this is the point where it creates the tables, installs all the packages. Okay, so there's not much more to see there. That just more or less runs immediately. And the next thing is I'm going to start the CDC task. So now I'm actually going to start converting real live transactions happening in my source database to my target database. I'm going to stay within the schema conversion tool to do this. I can do it from within the console, but it's really convenient to do it within the conversion tool. I'll create the CDC task. I'll give it a name. There's a few attributes here: source endpoint, target endpoint. I won't go into details about how they're set up. They're just objects that you set up in the console ahead of time. Crucial thing is I'm going to tell it I want to replicate data changes only. There's a few other options there. I could have done a bulk load and CDC, or I could do CDC by itself. In the demo itself, I've already done the bulk load, and all I'm doing is going into CDC mode to replicate real-life transactions as they happen. So that task is now running. The CDC task is now running. The next thing to do is I want to sell tickets. So this is actually where I'm doing a real workload on the source database. The way I'm going to generate that is I'm not going to bore you with me getting into a GUI and selling tickets. I'm just going to run a stored procedure that's going to randomly generate ticket sales. So this is SQL Developer. If you're using Oracle already, this will be painfully familiar. And I'm going to run a query here to indicate that currently there's like 500,000 tickets to sell from the pool, and the actual number of tickets I've sold so far is a nice clean 0. So you know I'm starting from a clean slate on the source database. And now I'm going to run the execute procedure that's going to generate a series of random ticket sale operations in the source database. Sorry about my typing, it's slow. So that's underway. So I'm starting to generate ticket sales at the moment. Now what I'm going to do is demonstrate to you that those ticket sales are being replicated from Oracle into Postgres. Do you want to hit play there? Thank you. So I'm going to fire up my Postgres admin tool this time and have a look at what's happening in Postgres. So I brought up the dashboard. You can see there's a bit of activity here. So these are the actual replicated ticket transactions hitting the target database at this point. Now I'm going to go into the query tool and run a query to see how many ticket purchases are now in my target database. So you can see here that there's ticketing transactions there. That's come back with 6,919 ticket sales. So that's indicated that the conversion is actually working now. Now that CDC task is running continuously now, and every time there's a ticket sale in the source, it'll be immediately replicated over. So that's pretty much it. That's the nuts and bolts of a standard migration conversion. I mentioned the DMS console. I won't go into, if you want to just hit play while I just talk. Everything we're doing in the Schema Conversion Tool is actually is also apparent through the console. All of the you can see here that there's a CDC task already running. You can see that in the console. It's got a whole lot of metrics to do with how that task is performing. You can see the numbers of incoming changes, how much memory it's using. So your DBAs can very closely monitor how that CDC task is actually performing. I mentioned the endpoints. These are just objects that indicate that have the credentials and URLs for respectively your source and target database. You set them up within the console and just refer to them in this SCT tool. And that's pretty much it. Thank you very much.